Professor Bell, this is trigonometry. This is the unit circle. The unit circle is a circle of 1 unit, right? Hence the name. So let's move this down a little bit. As a result, since it's a unit circle of 1, the radius is 1. So therefore the outer coordinate on the circle is 1, 0. And likewise all the way around. This would be 0, 1, negative 1, 0, and 0, negative 1. Let's make a better negative 1 than that. So this is the primary measurement tool in high school trigonometry, and the angles we're going to use on the unit circle are the ones from the special right triangles, the 30, 60, 90, and the 45, 45, 90. There are other angles in between other special right triangles. We're only going to use those ones specifically, and we only need to do 0 to 360 because after 360 degrees the measurements just repeat themselves for trigonometry. So first we'll start with degrees and go by 30 degrees. So if we add 30, we get 0, plus 30 more, plus 30 more is 60, plus 30 more is 90, which makes sense, that's a 90-degree turn. 30 more is 120, 30 more is 150, 30 more is 180, which is a half a turn. We have 30 more is 210, and 30 more is 240, 30 more is 270, 30 more is 300, 30 more is 330, and of course 30 more is 360, which is what we knew one turnaround was. So 360 degrees and 0 degrees end up being the same thing in the end because it's one turnaround back to the beginning. Okay. And next we'll do the 45 degrees because you either have 30 or 60 degree angles in special right triangles, and the third being the 45, 45. So if I keep adding 45, 0 plus 45, plus 45 more is 90, plus 45 more is 135, plus 45 more would be 180, plus 45 more would be 225 degrees, plus 45 more would be 270, plus 45 more would be 315, and plus 45 more is 360. So those are all the important angles in high school from the special right triangles that you need for the unit circle. There are ones in between, but they are ancillary at this point. Okay, next thing we want to know is the radian equivalent measures. Well, 0 degrees is also 0 radians. And 30 degrees, you can do the conversion for yourself, is pi over 6. Okay. Alright, and you can do that for yourself because 30 degrees times pi over 180 equals pi over 6 radians. That's the equivalent. Okay, so all we have to do now is add pi over 6 all the way around. So that's 1/6. The next one will be 2/6. 2/6 is really pi over 3. The next one is 3/6, which is really pi over 2. And the next one is 4/6, which is really 2 pi over 3. The next one is 5/6. 6/6 is just pi because it cancels out, right? And then we have 7/6. Nothing cancels there. Then we have 8/6. It's a common factor of 2, so that's 4 pi over 3. Okay. And then we have 9/6. Common factor of 3, 2 pi over 3. I'm sorry, 3 pi over 2, other way around. Get that wrong. That's 1.5 turns around, huh? Or 1.5 around of pi. Alright, so we have 9 pi over 6. Then we have 10 pi over 6, common factor of 2, so that's 5 pi over 3. Then we have 11 pi over 6. And of course the last one, 12 pi over 6, which is 2 pi equivalent. Okay? Alright, so next we need is the 45 degree angle. And you can do that for yourself. The 45 degree angle is the conversion of 180. We have pi on top. Let me fix that. Alright, so that's pi over 4 radians, or a quarter pi. So we have 1/4, 2/4, right? 2/4 is pi over 2, we already have that. Then we have 3/4, 3/4. Then we have 4/4, which is pi, we already have that. Then we have 5/4. The next one being 6/4, which we already have, that's 3 pi over 2. The next one's going to be 7/4. And lastly, 8/4, which is of course pi over 2. We already have that. Okay, so now we have all the radian in degree measures, and the next is the coordinates all the way around. Well, we have the coordinates at the axes. Those are obviously 1s and 0s. Now we need the other ones, which correspond to sine and cosine values, because in fact, this is cosine value, and this is the sine value, and this makes a special right triangle here. So this, in fact, is a 30, 60, 90 triangle. The next one makes a 45, 45, 90 triangle. And the next one makes a 60, 30, 90 triangle. Okay, so it makes our special right triangle. So I'm going to erase this. We're going to go to the bottom for a second. Alright, so we have the 3 types of special right triangles in the bottom, but there's only really 2 because the 30, 60, 90 flipped is the same triangle. So we know in every case that this is a unit circle, so the radius is always 1, right? So that length to the end every time is always 1. So as a result, we can use our 30, 60, 90 rule. So the small side, the small leg, is half the size of the hypotenuse. So if the hypotenuse is 1, the small side is a half. And the larger leg, which is across from the 60, is root 3 larger than the smaller leg, so that's root 3 over 2. So that's my x value, that's my y value for this point right here, which is my root 3 over 2, comma 1/2. And it'll be the same for the next one, because it's the same triangle, just flipped. The smaller leg is going to be half as much as the hypotenuse, and the bigger leg is root 3 larger than the smaller leg. So now this coordinate is 1/2 root 3 over 2. And then the 45, 45, 90, right? The result there is the 2 legs are the same, and they are root 2 smaller than the hypotenuse. So that's 1 over root 2. But we want to rationalize it for later use. So I'm going to multiply it by root 2 over 2 to rationalize it. So I get a root 2 over 2 answer. So that is the number we're going to use. So it is root 2 smaller, but we are going to rationalize it, use that as our answer for the actual coordinate. So root 2 over 2, root 2 over 2. Okay, so these are the 3 coordinates we need, whether it's a 30, 60, or 45. Okay, let's scroll back up. Okay, so the first one was a 30, right? The next one was a 45, and the next one was a 60. So if you made the actual triangle, that's a 30 right there. Next one being 45, and the next one being 60. So if it is a 30, then it is a root 3 over 2 and a 1/2. Let me make that a little bit better. Okay, that is the cosine value, and that is the sine value. Okay, the next one is the 45. That's root 2 over 2, root 2 over 2. And the 60-degree triangle was the 1/2 root 3 over 2. All right. So the result is, if I asked, okay, let's keep going. And let's see, we already had these. That was 1, 0. 0, 1. This is the -1, 0. And the 0, -1. So the other quadrants just repeat themselves. Okay, so if I remember correctly, this is the positive quadrant, is it not? This is the negative positive quadrant. And this is the negative quadrant. And lastly, this one is the positive negative quadrant. So we can just repeat the same answers. So this is 30 degrees, and this is also 30 degrees. So this is another root 3 over 2 1/2, but this is going to be negative on the first one. And this is still 45 degrees, so that's root 2 over 2, root 2 over 2, except the first one's negative. And lastly, 1/2 and root 3 over 2. First one's negative. We can repeat that in the other quadrants, changing the sign. So again, root 3 over 2 1/2, negative negative, root 2 over 2, negative negative, and 1/2 root 3 over 2, negative negative. And lastly, root 3 over 2, 1/2, second one's negative, root 2 over 2, root 2 over 2, second one's negative, and 1/2 root 3 over 2, second one's negative. Okay, make a better half than that. Alright, so essentially if we want to use this to calculation, if I asked you the sine of 30 degrees, you'd go to the 30 degrees, right? And you'd find your sine value, so the answer is 1/2. Consequently, if I asked you for the sine of 330 degrees, you have to go all the way around your circle to 330 degrees, and your answer there is negative 1/2. So what you see is, as you go around the unit circle, you get the same answers over and over again. The only thing that changes is the sign. If you go more than 360 degrees, the answers just repeat. So you just take out the 360s and you're back to some coterminal angle. Okay? All right. So as a result, in the first quadrant, sine, cosine, and tangent are all positive. Okay, there are no negative functions. Again, we're going to ignore secant, cosecant, and cotangent because they'd be the same. In the next quadrant, as a result, because this one is negative, right? That one is cosine, and that one is sine. The sine is positive, and the cosine is negative. Since sine over cosine is tangent, positive over negative would give me a negative, so therefore tangent is negative in this quadrant because of the fact that sine over cosine is tangent using the identity. Okay, the last quadrant, both cosine and sine are negative, so negative over negative gives me a positive tangent. And then lastly, in this one, we get a positive cosine and a negative sine, and then positive and negative is going to give me a negative tangent. Okay? I included some pictures on the last page to illustrate some facts about the unit circle. The first is a color diagram illustrating that the angles repeat themselves in each one of the quadrants. The only thing that's going to change for the answers is the positives or negatives. And lastly, I illustrated how it works with the grid and positive negative angles, because they would repeat again but in a negative manner.